Isn't that cool? So which one's the real Tom Cruise? Hands up thinks it's that one. Can't even see your hands. Middle one? Cool. And this one? Yeah, well, deep fake. This has got nothing to do with the talk, but while I've got the slide up, I'm going to slip over. You're here to talk about AI. And one of the things that you notice when you talk to people who want to use AI for developer purposes is that they have this in their head as the bar. If I can do that, if I can do deep fakes like that with an AI, think what I can do with code. Yeah. Right, let's switch over to the real one. Is that the one? Oh dear. Right. Okay. Right. So I can't do this. I have my eyes done. So that means I can't see you, and I have to put these on to see this. So this doesn't help. Anyway, my name is Steve Poole. I'm here to talk to you about how to use AI coding machines based on a lot of personal experience and a bunch of talking to people and talking to some of the tools vendors. I'm not going to show any tools. There's too much to do that. I mean, if you want me to bring up IntelliJ AI, we can have a look at it. But what I want to take you through is some of my experiences and then look at a lot at what that tells you about how to get the best out of these tools. Okay? And since this is an AI talk, the slides you're going to look at, apart from a very small number, were completely generated by AI. I applied the same principles to generating these as I now do when I'm generating code or test cases, which is there is a call tool, and you learn how to use it, and you apply the same principles that I'm going to show you to get that. It doesn't give you the best answer, the best response, but it's quick. Right. So this is what it said about me. Right? Senior Java developer, technical leader at some company, author of Practical AI for Java Developers, which is all complete bokum. Right? We all know this. We've all, I hope, all had to play with this stuff, and we know that if we're not careful, it just hallucinates really cool stuff. Right? I gave it some details about me, and it went, oh, cool, I'll pick things up. And what it picked up were not the things I was going to put on the slide. It just picked them. And I've left it there because it was hard to get to fix. And that's a theme for us all the way through this. When we talk about how you use AI tools in this space, the challenge of actually getting what you want. Right? So I started doing this some time ago, and I started writing about it. And I started at the beginning. So there's, if you go to Java Pro, you can find a couple of the things I've written. You can find a bunch of stuff I've written. But it started with some exploration. Let's try these tools. Let's ask it some questions. Let's see what we can get. And it distilled out to sort of like 10 things that I thought were important. And there's certain things I'm going to share with you. Okay. So now I can't read it. Yeah. So we're going to quick look at LLMs and copilots and things like that. I use copilot as the generic term because I'm not really sure what you call an AI that generates code and that you have interaction with, and copilot seems to be it. So whether it's trademarked or not, I apologize, but I use copilots. We'll look at these things. We're going to look at what can you get out of these things? How do you use these tools? What should you avoid? And those sorts of things. And hopefully you'll go away a little bit better informed, maybe not, but I hope you'll continue trying out these tools. Okay, so let's get some hands up. Let's talk about who you are so far. So Mr. Audience and Mrs. Audience and Miss Audience and other audiences. Who's an AI skeptic? Who thinks this is just smoke and it's all going to disappear? Who thinks those cars are not going to make it and horses are going to arrive forever? Okay. How about if you're on this end? Who's a power user? How many of you are using AI so well you shouldn't really be here? Okay, so in the middle. Cautious explorer, just trying it out. Yes. Regular user, people who've got, yeah, cool, right. So that's what I want to see. That's what I expect. I think a lot of what I'm going to say, regular users will go, I agree, or but, right? Right. As a cautious explorer, which is probably the majority of us, it is an interesting journey we're on because of the differences of what we've got. Right. Okay. So we could talk about where we are on the hype cycle. We could talk about the unexpected, unrealistic expectations we have of these tools and things like that. But let's skip that. Let's go with my use case to start off with. I decided I was going to test these tools out. So I picked some tools, right? A smattering of LLMs and some Copilot tools, and that was just my choice. There are lots out there, and they're getting more sophisticated, but it's like pick the tool of your choice, play with it. What you'll realize, I think, when you start to do this is that you're probably going to pick one Copilot-y tool, but you're probably going to use the others, right? Right. So I said, can I get an LLM to do these three things? Can I get it to give it some code? Can I get it to create the documentation? In which case I said, can you create some Java doc? Can you review the code for bugs and weaknesses? Can you generate some unit test cases? Right. That was, I mean, my prompts were slightly longer, but that's basically it. My code happened to be some code that I was writing. So for a completely separate reason, I was writing some code to be able to parse class files, Java class files, very thin. I just wanted a bit of information out. So I had some code that could do that, and that's just the top part, right? We all, it's just Java code. There's going to be some interesting side effects coming out of this. So anyway, so I go, piece of Java code sitting on my file system. Let's ask some questions, okay? Can you generate the main Java doc to describe this class? So I upload the code to the ones that are online, or if they're embedded in the IDE, I point the AI at them and say, do this, right? And Amazon Q, a little bit. Okay, so I've got some Java doc. Lovely example in line. Screwed that up a bit because that method signature doesn't operate that way. But okay, fine. Not the greatest, but it worked. I asked ChatGPT the same thing, and I got a load more, as you can see on the left there. It just went on. ChatGPT is designed to do this. It gave me a lot of good information about the code. As you can see, and you look at the detail. Oh, it's really good. I like this. It's got the same problem. It's got the same calls the method in exactly the same way that it's still illegal. Okay. But actually, it went more. It decided that my code, which just reads class files, was able to do more. This is intended to be used for bytecode analysis, class loaders, right? It's decided that my class file had more capabilities than it did because of the way that these things work, right? And it was my fault, not the tool's fault, okay? It thought that my HS class file was actually the Java class file, right, that you can get out there, right? And it started to get confused. And it got confused because I gave it no context. I just gave it a piece of code. It's an online tool. Here's some Java code. Do this for me. And it hallucinates. Okay? That's what happens. Right? Codium also did the same thing. And this one also invented the idea that I could write the stuff back to the disk. My code does none of this. It just hallucinated things that my code could do. And this is a common occurrence. And as we'll see, it's because I didn't give it context, right? And IntelliJ, right, which is the one that I use all the time now, is probably, I think, the best that I've used, certainly, and it's the one that's most integrated. It's very nice to use, so big plug for that one. It hallucinates. Like this one decided, IntelliJ worked out that what HS stood for was high school. right? Now, this is another thing that you'll see, is that when we talk about hallucinations, it can hallucinate anywhere. You can't think of these tools as being some sort of junior developer that you're bringing on. Because when those people, and when a junior developer makes a mistake, it isn't going to make a mistake like this. They aren't going to make a mistake like this, right? So that just happens when you catch. So the problem we all have is the hallucinations of that type that are, hidden away. Right. So then I said to these tools, okay, critique the code. Have a look at the code. Tell me what you think. And I got stuff back, right? I'm not going to tell you which tool did which, because uniformly it was pretty poor. Right, it came back with null pointer handling comparisons, and some of the tools would tell me good stuff, and other tools would completely get it wrong. Some wouldn't give me responses. Right, I'm asking the same question of all these tools. Right, error handling. It's part of the question. What do you think of the error handling? Right, some give me good responses, others don't. I mean, you can't tell. Well, the actual theme is that generally the ones that are IDE integrated seem to have a better time of figuring that out. And I don't know if that had because they had more access to code. I don't know, it had bigger context. But it turned out that all the way through this, right, typos, there was this very specific typo in there. There was a enum that was spelled wrong. Some of them detected it. Some of them, one didn't. Okay, you can't tell what you're going to get if you don't help these tools help you. Right. And then I said, hey, generate some unit tests. Right? And I gave it a goal, 90% code coverage. I don't know if that's going to work. I'm asking an AI to do something for me. I'm assuming it was going to figure it out. Right? And what did I get? I get test cases. And I'll tell you that actually when you get your head around this and you use it properly, it will generate really good test cases as long as you teach it properly. But if you just give it a, hey, go write some test cases and 10 lines of code, you get stuff like this, right? It just guesses, right? And you get this assuming thing, like mocks and assume, constant thing. You don't get what you want. What you get is boilerplate that may or may not be right based on the AI's assumptions. But at least it tells you it's assuming something. Okay? So, should we just give up? Right? Should we just stop now and go, okay, just talking to these things is not getting us anywhere. It's going to take too much time. Okay? Well, tucked away in there was the occasional good test case and the occasional good response. And so I thought, it can do this. I've just got to figure out how to get to do the good stuff I want and not do the poor stuff. Okay? So, this won't mean much to you, but when that was generated for me, I went, that's 100% spot on. The tool that did that, and I won't tell you which one it is, but the tool that did that had obviously managed to understand the other code that it had access to and could actually work out what it should do. And it was perfect. It just really trivial test case, but it worked. Okay. So there is certainly a difference between the LLMs that you have online and the copilots, okay? So let's do this. So now we're going to drop much more into the AI-generated slides. And I have some control of the content, obviously, and I have some control of the layout, but it's a bit wordy. So I'll try not to read the words, and I hope you don't get too distracted. But they are different, okay? When you look at a copilot tool, what's the difference between a general LLM? If you look at Copilot, any of these tools, you'll see that the models they're using are almost always a mainstream LLM. Some of the tools let you plug in ones you can do locally, you can train your own, but most of them are going to go and use a big LLM because they need the text understanding, the human understanding. Okay, and so a lot of the differences, apart from the ability to be having access to your context, the bigger piece of code that you've got, right, is about how they're trained. Right. So the main thing is that you've still got an LLM, you're still text-based, The coding ones have code specific. We'll get to that in a second, but the coding assistant tools have been trained on more code specific data. So more code for sure, but also more code related doc, which is really important. Right? So you can use LLMs for these things, but you're going to get better return if you use the Copilot stuff, because they have been designed to do what they said. It's your job to figure out how to get that to happen. So I have 10 things, which we've got 34 minutes to go through, okay, that I sort of came out. And I feel my views on these have changed a little bit, but I want to go through them because it's the sense of where we are and what you need to do. So let's pick the first one. AIs don't reason about code. That is absolutely true. You have to understand AIs are statistical tools. They are statistical reasoning. You give them all the code, all the text in the world, and it works out what the next thing should be based on all the context and circumstances and past data it's seen. It doesn't understand code, right? It's very, very good at what it does, but as far as it's concerned, code is just text, right? There's no reasoning. There is some sort of smarts it gets because it's read all the code that you've ever written and all the stuff that you've ever written about code and ingested all that, and it's now worked out what the average internet developer does, and that's what you get. Okay? No reasoning. Okay? So where it starts to fall down immediately is if you ask it to do something complicated. Complicated logic it's not good at. Even writing test cases can be complicated. If you need to use somebody else's API, you have almost no hope of getting it right, unless you can provide the documentation that it needs to do that. So if you give it lots of doc, then about the API, it will work. What you have to understand, which is in here somewhere, is that though we give LLMs code to understand, and they don't understand the code, what really works is when they have the code and the doc that goes together, so they can put it in a different context, but it's context. You're giving them code, giving them an API, here's a Java class, go do something with it, is never going to work. You have to give it the human stuff. Okay? Yes, and the other thing that will bite you is latest updates. I've got a wonderful slide about that. You have to think also about when this thing was trained, what's it know? Do these AIs have extra agents? Can they be updated? You know, and if not, then you're stuck in the past at some level, and that will bite you too. Right. So it comes down to the training data. There's a whole bunch of stuff that can go wrong with LLMs in general in terms of bias and things like that. But it's these sorts of things. It's where's the data coming from? Is it all GitHub or is it something smaller? Okay. Is it code? Is it text? Is it both? You need all this sort of stuff, right? And like I said, like frameworks and APIs. If your Copilot it doesn't know about, I don't know, Java 17 because it was finished before Java 17, there's no point talking to it about latest Java and expecting it to give you latest Java because it doesn't know what that is, right? Yeah, it's much better at popular languages than it is, I don't know, less popular languages. So I challenge you to go and get your Copilot and ask it to create some Haskell for something, you know, and see what it gets, right? Oh, really important point, which I don't think I have a slide for this. Never, ever, ever ask a code generator to generate code that you could not have written yourself. Do not assume that this tool can lever you up. The ability of this tool is to make you faster, more productive, but if you can't read the code and understand the code that's generated, then you're down a very, very slippery rabbit hole. So never do that. You can go talk to an LLM and say, teach me how to do this thing, teach me how to understand it, and that's perfectly reasonable, but don't ever ask it to generate code without you understanding what you're expecting. Right, okay. So LLMs are trained, we have all this data, There's a whole bunch of pre-training, so the data is selected, pre-training, fine-tuning, right, which is where you can basically make sure that you get it just about right. You know, you try and get rid of the biases and stuff like that, blah, 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 right? LLMs have this structure, and when you look at what AI tools, the co-pilots, they are slightly different, but it's the same model, right? They put code in, right? And they do fine-tuning on this sort of stuff, and they do context learning, right? They are taught differently, but they're taught in the same way. So they're the same tool. It's an LLM with extra, understands about your code, but as I keep saying, it understands about your code because it's text, okay? Right. We do not see anybody giving these LLMs an AST. So if I go to Java, I could parse Java code and construct a structure, you know, an abstract syntax tree of your code, and I could put that into the LLM, and it wouldn't know what to do with it unless it had a lot more of them. Right? Because it doesn't need an AST. It doesn't need to understand how your programming language works. It just wants millions of examples because it'll figure out whatever it thinks the right answer is. Okay? So you do get none of that. So some people say, why don't we just do that? If you're building your own one of these things, you could create a RAG, and you could say, I'm going to pass this code, and I'll go and get a Java AST parser, and I'll put it into my RAG, and hey, suddenly this thing is going to be smart. And it's like, nope, that's not how it works. If you want an AI that's going to be what we really want, which is this whole, hey, we want it to reason about code, we have a lot more building blocks to put in there, right? So it's a long way to go. There is some things happening right now that will make it a bit easier for us, but the whole idea of eventually we're going to have an AI that understands code like you and I do, that's too far off. There's too many challenges for us to do that. So that isn't going to fix, right? So your challenge is, how do you get value out of using these AIs? Right? What is it that's the best way to do, right? So my starting problem was that I had a very short prompt, right? I wasn't focused. There is this idea, if you think about the people you talk to, they've already got some context. They've already got shared history and stuff like that, and you make use of that. You shorthand things. So when you put a prompt in, you're having a conversation with something that knows nothing about your specific history or your environment, but we make mistakes and we assume it does, okay? So you have to have very, very precise prompts, right? And if you're going to get to generate code, don't try and generate large amounts of code. Generate small pieces that you can control. And there are good reasons for that, and I'll come up in a second. Use AI for structure. Ask it to do the bit that's boring for you, but that you can trust it. Don't get it to write. You can get it to write code, but you might go, hey, create me the JUnit boilerplate test cases for this and tell me what I should put in them, right? And then you could go through each one and say, okay, create that one, create that one, create that one, okay? If you say to an LLM, create all this stuff up front, it's not going to work. And it's going to waste your time trying to fix it. So that precision in the prompt, make the prompt bigger, make it very specific. Why don't you go and ask an LLM to create the prompt for you? Have a conversation with the LLM, create the prompt, put it in the tool, right? You don't have to do it all by hand. The tools can help you, okay? Because these prompts don't work well even if they're very precise, okay? So if I go to an LLM and say, generate an image of the Mona Lisa, right? There's a picture of the Mona Lisa, right? I might actually get that. And the reason I get that is because the image AI, has a label that says, this image, the Mona Lisa. It's probably been fine-tuned with a bunch of images that are common, so it knows to give you that one, okay? But that's only a very, very unique situation. If I did the equivalent in code, I get rubbish. What I want is a prompt. So if I ask LLM to describe that picture, I get a significantly larger prompt. And I'm not saying that's the detail you need to go when you create the prompts, but you need to start thinking in terms like this, exactly what you want, okay? And even when you do this, and you take this back into an LLM or, and you say, create this image, do you get the Mona Lisa? Of course you don't. It's impossible for us to write down in words what the Mona Lisa looks like. It's impossible unless you were to go through every single pixel and say this pixel we read and this, okay, you get that. And then depending which LLMs you use, you get different responses. And you even get unusual artifacts. Like, I have no idea why there's a white cat in that one. It just is, okay? Right, and every model you use gives you different answers. Right? But this is what you have to understand. This is what this LLM is going to do for you. So you've got to figure out how to manage this environment to get not necessarily the Mona Lisa that you want, but a version that's close enough that you can live with. Right? We're very flexible if it was text, humans. The human language is very flexible. Human languages are very flexible. Images are very flexible. We're willing to give a little, but code we can't. So you have to figure out how you're going to do that. Okay. Right. So be highly specific. No vague responses. Specific parameters, frameworks, versions. Do it this way. Use this. Okay. All right. Reference existing code. Give it the code. Do things like this, please. If it's integrated, you can say that class, create a copy of it and change it to do these things. It's easier. Okay. And then be prepared to do this iteration, which is why I say you can't do big stuff, you've got to do small stuff, because you're going to iterate, okay? Don't say latest, because it doesn't mean what you think it is, right? You can say use the latest, and it'll go, well, the latest I was learned was this thing here, and maybe somebody says I shouldn't use that, and use a version number, right? Or even better, time-bound. LLMs are much better at understanding time limits than versions. If you say, use something that was released last year, you're going to get a better result than if you say, use this version. Okay? This, for some reason, tends to work better. Okay. Don't say don't. The reason you should never say don't to an LLM is that it has to go figure out what it is you don't want it to do first. And that ends up in the memory, and because we're talking statistical, suddenly the thing you didn't want it to do is sort of there, okay? And these things happen, so try it, right? Create me an image that doesn't have a white elephant in it. Right, and see how often you get a white elephant. Be very specific. Create a image without a white elephant. Make sure it's got 4 doors and there's no white elephant, blah, blah, blah. Eventually, you will get an image with a white elephant because you've overrode the statistics of this stuff, okay? So don't do that. Be positive about what you want, not what you don't want. Okay. I think I've said this bit. Plan to iterate. Yes. Don't go in going, I'm going to write a prompt and I'm going to get a whole application. You might get parts of an application, which you probably will, and then you'll find you want to change a bit, and then you've got how do I change the design without regenerating everything? And you try it and you get something completely different. You get an alternate reality that's similar to what you want, but not quite, but your only lever is this big prompt. So by going down a level and focusing on creating prompts for the smaller pieces you want and keeping them, right? Keep those things around, right? And talk to it, right? Assume, where does it say? Oh, okay. Continuous. If it goes wrong, doesn't compile, go back. This didn't compile, what do I do? Eventually you'll get bored with that, right? And you'll go, okay, I'll start again, and you'll be more specific, right? But if you don't feed back what happens, then you're not going to get the responses. You're tuning this parameter, this prompt, and you're working with this LLM that is a statistical reasoning machine to get the answers you want. Okay. Which I sort of said, yeah, so obviously you can go to the console on a chat, or you can go to ChatGPT, but one of the other things you'll be doing is you've got your writing code and it's giving you prompts, okay? That's the sort of thing that makes sense, right? So help it do that, right? Making sure that you're writing code that it can predict. Oh, and by the way, if you have more than one Copilot license, Google and Microsoft and IntelliJ, don't turn them all on at the same time, because then they fight, and which is interesting, but doesn't get you anywhere, right? The thing is, it's easier to veto. You've got to make decisions about it didn't work and still move forward. So smaller is better. Okay. So that veto thing you've got is your choice. You're saying, I asked an LLM to do something for me. It did not work quite the way I want. If it's an inline suggestion, veto's easy. You can go, forget that. That's not what I want. If it's part of a large chunk of code you're generating, it's really hard to apply that veto without losing a load of stuff. So that's why you have to figure out how to get to the point where you're in control. Okay? And go back to it. That wasn't good enough. Do it again. Tell it why it wasn't good enough. Feedback. Tell it to do it better. You can go to an LLM and you can say, generate a test case for this class and do it 100 times to make sure that you get it right, and do this to see and to assess it. Give it a task. Right? Don't just sit there and write the prompt. Talk to your AI and say, do this, that was good, that was bad. Right? Tell me how you're thinking. How are you going to solve this problem? Ask it questions and guide it. You will get so much better output by being part of its process. Okay? Yeah, and I also say, when you find prompts that work, save them, because they are partly of your learning curve, but they're also the thing you're going to want to come back to, right? Because some of the tools, like the Copilot tools, they don't necessarily keep a copy of this stuff. It's just around, and you scroll around and you're going, what was that prompt I used? So get used to saving these things. So yeah, ask the AI to tell you what it's going to do. Be part of that process. You're going to ask it to write test cases. Okay, so you tell it up front, I want this JUnit thing, and I want this, and I want you to do this, and I want you to do this. Do you understand? Tell me what you're going to do. The LLMs are getting better at doing that, and you do get some of that feedback. But you want it to do that. And you want it to critique itself. Ask it. This is the plan you've got. What problems do you perceive might be there? How could we fix them? Your job is to get this LLM to do what you want it to do, and you have to do that by working with it. If you take a prompt and it doesn't work, and you change the prompt and it doesn't work, you're not getting feedback. You want to talk to it and say, why did that not work? Okay? Right? So, best practices and things. If you want it to code your certain way, give it the style. Otherwise, you're going to get what you want, whatever it generates. Right? You have to give it that information. Yeah, so what I found was, you get this stuff generating code, and then it generates code, and then it generates code, and then you go, oh, I like what I've got, but that bit's wrong. Okay, and now I need to, actually I didn't commit any of this stuff, so I need to untangle myself. I want to weave back through the code generation. So I find generally commit, obviously create feature branches and try. Do not be afraid to explore. You'll get value by going, I've got a new prompt in mind, I want to create something, I'm going to create a branch, I'll try it. I will commit as I go through, roll back, that worked, let's go back to that point, let's do something else. That gives you more traction and gets you further along. Okay? Yeah, and I say keeping those prompts, you'll be surprised how if you do that, you can go back and look at them and realize that there were certain things that you said that worked better. Or actually hey, look, duplicate side. There we go. Right. Teach the AI. Tell it what you want. Give it the data that you want it to think of, right? Give it context, right? Ask it what context. So if you've got one of these copilots and it's in your IDE, ask it to summarize the code base that you've got, right? Get it working for you and making sure that it understands those things, okay? And go back to it. Most of these things have some system prompt where you can put in general rules, right? That's the sort of place to put those things in and work with it to make sure that you're getting what you want, because depending which model you get, you're going to get different responses. So you've got to figure out how to corral this model that you're using. And unfortunately, if you switch models, you might get something completely different. And if the model upgrades, you may find you have to reapply this. So keeping the data that you use to keep this AI on track is vital. It's your training material, whether it's in a prompt or wherever it is, because you're going to need to reapply this occasionally. Okay, teach the AI, yeah. So showing examples. If you want it to mimic something, give it the code that you want to mimic. If you want to give it, say, boilerplate for an exception, do it like this. If you want method names, formats, you can give it examples. You can certainly write it down, but if you can construct code examples and give it to a code, it will understand that better. Okay, right. What else we got? Include documentation. Yes. Well, I said right at the beginning, if you do not have the doc to go with your code, or you have doc and it's out of date, things aren't going to work. So if you're thinking that you can use Copilot or a Copilot against your commercial code, that's fine, provided that you figure out how to give it all the doc for it. If your code doesn't have Java doc or a good doc and a design doc and things like that, how is it going to learn? What it's going to learn is the wrong things, right? And if your Java doc is wrong, it's going to learn wrong things, right? I cannot stress enough just how important it is to have the doc and your code synced up. If there's one thing that you could do that wasn't LLM based, tomorrow is to go look at all the doc you've got for the code that you want an LLM to learn about and make sure it all makes sense. Okay. Right. What else we got? Actually, I think I've just said this. There we go. Write clear documentation. It doesn't understand your code as code. It understands your code as text. It doesn't understand code at all. But if you give it code and text in context, it can figure it out, because that's what it can do with any of this, whether it's code or any other text. It can make those contextual connections. If you don't have good doc, but not just your doc, what about the doc of the APIs that you're using, or the open source projects that you're making use of, right? Those things also need to have good doc, because otherwise you get non-optimal things. Because if somebody puts out a new project and doesn't update the doc, and they've made some breaking changes or whatever, how are these LLMs going to find this stuff? So your challenge is also to start thinking about the third-party stuff you want this thing to generate. You want to generate React or Spring. Make sure that you're choosing projects that have good documentation too, because otherwise you've got to figure out how to do that. Yeah. And all this way through, provide examples. Code, text, code, text, code, text. That works so much better than trying to just ask it to go find this stuff. Tell it what you want. Right. So teaching the API, I think I've said most of this. Always double check generated code against current documentation. Ask it. You've generated this code. Does the code that you generated match the best practices for this tool? Right? You can ask it that. You can ask it to give it back. And then when it comes back and says, here are the problems, you can say, can you go fix them? Right? You have a relationship with these tools that perhaps you're not using. Right? Yeah, I've version numbers. In general, my advice would be when you decide that you want one of these tools to generate things and pick a version of Spring or Quarkus or whatever, do it by the date basis. Don't ask it to generate POM files and things like that. It'll just get it wrong. Right? You pick up that piece. Be wary of configuration files, for instance, because configuration files, kube YAML files, all those sorts of things, a lot of those are very arcane, and the chance of a hallucination screwing that up is high. So don't take the risk. You can do that yourself. Focus the LLMs on the pieces that you really need it to do as sort of boilerplate. 7, yes. Again, I think I've said all these things. It's make use of the AI, right? Use it in all the places. You've got an LLM to generate code. You've got an LLM that can do design doc for you. It can do research for you. It can critique things. Use it more in the human space and the code space, and you'll get so much more value out of these things. I use these tools all the time as research tools, and they can make such a big difference in that space, right? And debugging, yeah. If it goes wrong, ask it. You get an error from your front end and you have no idea what this, ask it. It will give you great insight because it knows how to debug the information quicker than you can, right? Yeah, okay. So, don't just pick the Copilot and go, that's it. Use the LLMs, use the ChatGPTs. There are other AI tools. There are AI tools for code analysis and things. Go have a look. There's a lot of cool AI tools out there that can help you. They have the same caveats. You have to learn how to make them work. But if you don't make use of the other things, you're going to miss out. So, last few points. Number 9, non-functional aspects. This is very true. It's really, really hard to get an LLM to add in security things or logging or stuff like that. It can, but you've got to ask it to do it. And you've got to figure out whether you can put that into a prompt and get it to do it every time, or whether it's going to be better to write the code and then come back and ask it to apply. And you could do that. You can take a piece of code and say, can you add some logging to this thing? And you will get some reasonable results, okay? And the same with all these things. There's no way an LLM is going to give you high-performant code unless the usual way of doing something is high-performant, because it does not understand about code. So the only thing you'll get is a pattern that says somebody said this is the way that you do fork join or something, right? So that's your problem too. Okay. Yeah. Oh, I think we said that right. Okay. The bottom of all this is this bit. You've got to have a safety net. How are you going to make sure the code that's being generated for you is actually good? And the best way to do that is to focus very hard on the clean code type approach, right? Because you want to see the problems coming. You want to run the static analysis tools and the human reviews, and you want to get all the noise out of your system as much as you can, so that these things that are going to generate it. And as I said, hallucinations can be anywhere. I mean, absolutely anything. And some of them come out and you go, I don't even know how that compiled, but that's wrong. And they're at every level. So how are you going to find those things if you've got 10,000 other problems in there? So clean code, that idea of having, no bugs, or at least having a low level of problems, allows you to see the things that these things are going to generate. Right. Takeaways. So nearing the end. I think you're probably getting this. Understand AI limitations. And there's the biggest stuff where I talked about, like prompts. There's also the smaller pieces, which depends on the model you're choosing. So you've got to learn that yourself. You've got to figure out which is going to work for you. Okay. Use precise prompts. Don't say no. Don't say negative things. Okay. Maintain a good development discipline. This tool is a two-sided razor. So make sure that you're able to deal with it as you develop and actually be able to roll back if things go wrong. You need to have that control. And use as many as you can, because why not? Right. Okay. Last 2 slides. The good news is that some of these problems are going to get solved. I encourage you to go and Google for intent integrity chains, which is a thing that's bubbling around now. The idea is you can take an agentic AI, so that's an AI that can call out and do things, and start to give it some smarts. So you could say, for instance, go and generate some code, and one of the agents could be a compiler. At least you know the code is compiled. Okay? And maybe it's something else, but you could get the sense that we can start to build these things together. And because we can start to iterate through those processes, the theory is that you should be able to get to the point where you can write a proper business level spec of what you want to have happen. And because of these integrity chains and these agentic processes, that you could actually hope that the code that gets generated could be tested and could be assessed to match the intent. Right? And it's early days, but this is certainly where people are going, because it's obviously easier to ask an LLM to go compile the code before it puts it in your tree and to prove that those things work than to do it the other way around. Right, and the last one, just to prove where this is going, let's see if the sound's still working.
Yo, I'm a paparazzi. I don't play no Yahtzee. I go pop, 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 pop. My camera's up your crotch.
Okay. The reason I put this up was I just want to show you where we're going. This is like April 2024. Taking an image of the Mona Lisa, applying it over, using somebody else's face, applying these things together. One image turned into a 3D model and animated and lip synced and all that sort of stuff. The capability for our tools, the Copilot tools, is certainly heading in the right direction, right? But we're not at that stage. But the possibilities, the potential is there. And it's just a matter of you guys starting to get your head around the fact that you have this small 2-year-old that's going to be only do what you say and is probably going to be naughty. Anyway, thank you very much for listening. I will put the slides up. I said they're generated, so I can share the link if you wanted. My Twitter handle's in the corner if you're interested, and I will publish them somewhere. And if you want to read any of these supporting articles, they're on Java Pro under my name.